Friends, today I would like to introduce the concept of sample survey and an overview of different methods of sample selection. Suppose we wish to estimate the parameter or say some characteristic of a population, then we have two approaches. That is, either we can go for 100% counting or say complete enumeration, or can take a small part of the population, which is called a sample, by using some technique. This is called sample survey or sampling. Now you see many times complete enumeration is not possible either due to nature of the population units, that is units are destructive in nature, or we require lot of resources to go for 100% enumeration. For example, in case of blood testing, we take only few drops, not the full blood of the body. If we take full blood, then the person will die. So only scope is sampling. Now the question is arises how to draw a sample. There are various methods for selecting samples. We classify these methods in two categories. The first, probability sampling, and second, non-probability sampling. In probability sampling, each and every unit of the population has some known probability of being selected in sample. That is, we select sample by some probability based rules. However, in non-probability sampling, units are selected not based on rules but by some other approaches. Further, the probability sampling classified into three categories, that is simple random sampling, systematic sampling, and probability proportional to size sampling. Now I will discuss each of them one by one. In simple random sampling, each and every unit of the population has an equal chance of being selected in the sample. The simple random sampling is again of two types, that is simple random sampling with replacement and simple random sampling without replacement. In with replacement sampling, units are returned back to the population after recording the information, while in without replacement, units are not returned. So naturally, without without replacement sampling is more efficient than with replacement sampling. Now, if there is heterogeneity in the population, then simple random sampling may not be suitable for getting efficient estimators. So, efficiency of the estimator can be increased either increasing the sample size or decreasing the variability, that is, removing the heterogeneity from the population units. We can increase the sample size, but it is quite difficult to increase it beyond a certain limit as the cost will increase and the non-sampling errors will also increases. Thus, purpose of sampling is defeated. It means we have to decrease the variability or remove the heterogeneity from the population. It can be removed by dividing the population into different subgroups based on similar units, and these subgroups are called strata. And it is assumed that units in each stratum are more or less homogeneous. Now we select random samples from each stratum, and this type of sampling is called stratified random sampling. Now we have to decide how much units are to be selected from each stratum. This problem is known as allocation. There are various methods of allocation like equal allocation, proportional allocation, and name and optimum allocation. In equal allocation, we divide the sample size equally to all the strata. However, in case of the proportional allocation, we select the different subsample from each stratum as per their proportion.